So this video is on Chapter 7, Homework 2. Again, this video is meant for you guys to first try do the problems on your own, seeing which ones you get stuck on, and then coming and looking at the video to find the ones that you're needing help with. So on this problem, it says condense this to a single logarithm. So we want to write it as a single logarithm. So this was like what we were doing on the classwork. So if I have a minus, then this is going to be on the bottom. This is going to be the division. Anything that's a plus is going to be on top of my fraction when I write it as a single log. And the power is the number in front of the log. So this 3 is going to come over here and make this an r squared. So I'm going to write log of, and I'm going to have a 4. I'm going to have a 3 on the bottom, okay? This pi is going to be on top, and then this 3 log r is going to become an r to the 3rd, and that is my answer. Okay, so again, anything that's positive or has a plus is going to be on the top multiplying. Anything that's on the bottom is going to have a minus because that's being divided. Okay, next problem. So this 1/2 is going to come and make this x to the 1/2. And a little reminder that if you have anything raised to the 1/2 power, that's really the square root of x. So we're going to write it as a square root. This 2 is going to become the power of this x plus 1. So this is going to be log base 5 of, and again, this 1/2 means I have x to the 1/2, which is the square root of x. This 2 is going to become the exponent here. So this is going to times with x plus 1 squared. So again, this 1/2 power makes this a square root x. This becomes the power 2. So I have this, and that's my answer. Now, these next ones are like the problems we were doing the other day in class, where you have a base to a power. So whenever you have a base to a power, if you cannot make these bases be the same, which we definitely cannot make these be the same, you're going to use logarithms. And your goal is to get your base by itself. Then you're going to use logarithms. Now, in this case, I'm going to log both sides. So I'm going to have log of, and I'm going to log base 10. Okay, so log of 5.825 raised to the x minus 3 power equals log of 120. Now, this x minus 3 is the power, so it's going to move in front. So I'm going to go parenthesis x minus 3 because this whole x minus 3 is going to be multiplying with my log of 5.825 equals log of 120. So now I'm going to try to get my x minus 3 by itself first. So I'm going to divide by this. So I'm going to have x minus 3 equals log of 120 divided by log of 5.825. Now this is just a number. I'm going to keep this here and put it in my calculator at the very, very end. That way I don't have to round until the end. The last thing I need to do is get rid of this minus 3. So I'm going to add 3. So x is going to equal log of 120 over log of 5.825 and then plus 3. So I'm going to put this into my calculator. Okay. And I'm actually going to do this as a fraction. Let me just make this a little smaller so I can move it over and get my calculator in here. Okay, so to do this as a fraction, you can do alpha y equal, and then I'm going to hit number 1 or just hit enter, and I'm going to take log, this log right here, okay, log of 120 over log of 5.825, and then I'm going to arrow out, and then I'm going to have my plus 3. So Again, I like to use the fraction. That way it will do the proper order of operation always for me. So I'm taking log of 120 divided by log of 5.825 and adding 3. And again, to get to that, I did green alpha and then y equal. And this is what I got. They want it to the nearest thousandth. It's 3 numbers after the decimal. So that means I'm looking at the 6. So the 6 is either going to stay or it's going to go up to a 7. And if you look at the 8 after it, that 8 is going to push us up to a 7. So this is going to be 5.717. So my answer is, let me get a different color, x equals 5.717. That is my answer. And if I wanted to check that, okay, I can put in my calculator 5.825 raised to, and I want this answer, but instead of coming up and snagging it, if I come down here to where the negative sign is, there's the word answer, but I need to hit the blue second button first. So I'm going to hit the blue second button, and then I'm going to come here and hit this, and then it's going to take the last answer I did, and then it was -3. All that's still in the exponent, and I should be getting a 120. So I know I have the right answer. Okay. Next one. It's like the one I just did. The thing that's different is I have a number in front. So I need to get my base to the power by itself. So I'm going to divide by 18, divide by 18. And when I divide by 18, I'm going to get 1.2 raised to the 2x minus 1 is equal to, and I'm going to go 900 divided by 18, and I end up getting 50. Now that I have my base to a power by itself, I'm going to log both sides. And I'm going to log 10 both sides. So when I log this side, this 1.2 to the power moves in front. So I'm going to get parenthesis 2x minus 1. Put that in parentheses because that whole thing's going to come out and multiply with my log of 1.2. And on this side, I have log of 50. So then what I'm going to do is I am going to divide both sides by log of 1.2. So I'm going to get 2x minus 1 equals log of 50 over log of 1.2. I am going to add 1 to both sides. So then I'm going to have 2x is equal to log of 50 over log of 1.2, and then I'm going to add 1. Now, at the end, I'm going to divide all of this by 2. I'm going to put this into my calculator first so that I don't have a fraction and a fraction and dividing this whole thing by 2. Okay, so let me first get this answer, and then I'm going to divide by 2. So again, I'm going to do alpha y equal, and I want number 1. I'm going to type in log 50 over log of 1.2. I'm going to arrow out, add 1. And I get about a 22.45, let's say 7 if I round this up, but I'm going to keep it in my actual calculator. And then what I'm going to do is I'm going to divide by 2 now. And when I do, I get 0.228. So I get 11.228. And that's my answer. Okay, and again, to check it, I can take 18 times 1.2 raised to the power 2 times the answer I just got. So I'm going to hit the blue second key. I'm going to come down here and I'm going to hit answer. Okay, and then it was a -1, and I should be getting a 900. Okay. Now, these ones, x is not in the exponent, so I'm not going to be using logarithms. I am going to root each side, okay? So you can take a decimal root of something. You don't have to just take a third or a fourth or a fifth root. You can take a 3.8 root. So I am going to take 3.8 root of x to the 3.8, and I'm going to take 3.8 root of 240. Over here, this undoes and I get x equal. And then on my calculator, probably the easiest way to get to it is if you just hit math, number 5, and I'm going to take the 3.8 root of 240, and I end up, again, they want to the nearest thousandth, so I'm going to look at this 0. This 3 is going to keep this as 0, so it's going to be 4.230. 4.230. And I can always check this answer, okay? I can raise, and if I just do raise to, it's going to take my answer, because it's already computed it, to the 3.8, and hopefully I should get 240, and I do. Okay, the next one, okay, when I'm doing this, this is being raised to a 12.5. I know it might be hard to see that decimal, but on the worksheet, if you zoom in, you can see it a lot better here. So the first thing to do is get this x minus 2 to the power by itself. Okay, I need to isolate this, so I'm going to divide by 4. And divide by 4. And I'm going to get x minus 2 to the 12.5 equals, and let me do that math. So 2486 divided by 4, I get 621.5. So 621.5. Okay. So now what I'm going to do is I am going to take the 12.5 root of both sides. So when I take the 12.5 root of this side, I get x minus 2. And then I'm going to take the 12.5 root of this side. And I'll put that in my calculator here in a minute. The last thing I'm going to do is I'm going to add this 2 over. So I'm going to take the 12.5 root of 621.5 plus 2. And this plus 2 is outside of my square root. Okay. And again, let me put that in my calculator. So to put that in my calculator, again, I'm going to hit the math button. Okay. And it's going to be number 5. And I'm going to go 12.5. And then I have 621.5. I'm going to arrow out of that. And then add my 2. Okay, make sure you arrow out to get that plus 2, or just hit enter and then go plus 2. And so I get 3.67. This 2 is going to be pushed up to a 3 because of that 9. So it's going to be 3.673. And that's your answer. Now again, if I want to check it, I can check it. I'm going to go 4 times. And again, I'm going to hit the blue and the negative sign for answer. I'm going to take that answer, minus 2, close my parentheses, raise to the 12.5, and I should get 2,486, and I do. Okay. So letter C. This is like one of the ones I was talking about in notes today, where if you have a log equal a log, and they are the same base, and these are both base 10, then whatever I'm taking the log of here and whatever I'm taking the log of here, those two things need to equal each other. So I am basically going to write 12x squared plus 5x equals 2. So I end up with this quadratic. So now I'm going to subtract the 2, so I get 12x squared plus 5x minus 2 equals 0. And now I'm going to factor this. Okay, so I'm going to do a box to diamond. And I'm going to have 12x, here, I'm going to do it in, make this a little bigger. And I'm going to write it in black so I can see it. So this is going to be 12x squared and a negative 2 because of this. These multiply to a negative 24x squared, and they have to add to a 5x. So that should be an 8x and a negative 3x. 8x, negative 3x. So now when I'm trying to find the outside, focus on your 12x squared first. It could be a 1 and a 12, but that's not going to work with these numbers. 2 and a 6, but again, that's not going to work with these numbers. So I'm thinking a 3 and a 4. So my 4 is going to go here to help with the 8, and my 3x is going to go here to help with this. So 3x times negative 1, 4x times 2. So I'm going to end up getting 4x minus 1 times 3x plus 2 equals 0, and I'm going to solve. So what makes this 0? Well, if I set this equal to 0 and I work it out, this is going to be a 1/4. For this one, if I set it equal to 0 and work it out, this is going to be a negative 2/3. You can never take log of a negative number. So I want to make sure that when I put this 1/4 in here, I am not getting a negative here. Well, 1/4 will not get us a negative. Let's see if the negative 2/3 does. So let me just put that in. So I'm going to go 12 times, and let me do alpha y equal. And this is going to be a negative 2/3. Close my parentheses, squared, plus 5 times, again, a negative 2/3. Oops. A negative 2/3. And I end up getting a positive. So both of these are answers. But if I was to put one of these into my log and that ended up being negative, it would not be an answer. So both of these are answers. Okay, on the next one. Okay, this looks awful. Please do not multiply all this out. Notice I've got something times something times something times something squared times something equals 0. The only way when I multiply something all together out and I get 0 is if one or all of these are 0. So this is really the zero product property. So I'm going to figure out what makes each of these factors 0. Well, for this first one, x would be 0 because 3 times 0 would be 0. This one would be a negative 1. This one would be a 7/2. This one, when I set this to 0, would be a negative 4/3. And it's squared. It just means that you would have actually had this twice as an answer because you have a 3x plus 4 and another 3x plus 4, but you only need to list it once. This is going to be 13. This is going to be x equal. Let me space this out. X equal 13, and this one's going to be x equal negative 7. So all of these are your answers. Because if you have things multiplying together and you get 0, one or all of them could be 0. Okay, so the next problem, finding inverse. Okay, so to find the inverse, you want to switch your x and y. And this is really a y. Okay, that's really your y. So when I switch them, I'm going to get x is equal to 2 over 3 minus y. And now I want to solve for y. So what I'm going to do is I'm going to multiply both sides by 3 minus y. Okay, so I'm going to multiply this by 3 minus y, and then I'm going to multiply this by 3 minus y. When I do that, this and this cancel out, and I'm going to get 3 minus y times x equals 2. So I'm going to distribute this. So I'm going to get 3x minus xy, or yx, equals 2. I'm trying to solve for y, so I want to get this by itself, so I'm going to minus 3x. So I get negative xy is equal to 2 minus 3x. And then I'm going to divide both sides by negative x, divide by negative x, divide by negative x. And when I do, I'm going to end up with y is equal to 2 minus 3x over negative x, or usually we don't like the negative on bottom, so if I move the negative on top, I could write it this way. Let me just get a different color. Okay, I could write it as y equal, and again, if I'm moving that negative on top, this would become a negative 2 plus 3x, and I would write it maybe as 3x minus 2 instead. That's a little nicer looking. So again, if I move this negative on top, this becomes negative, this becomes positive, and then the bottom is going to be a positive x. So either one of these is an answer. Now, the last one is really a tricky one. This is kind of more of an integrated 3 math analysis question. I'm going to go through it, but it is something that you need to remember some ideas that you might have learned in integrated 2. So the first thing I'm just going to kind of jot down for us, okay, is this idea that we don't like to have square roots in the denominator, because we're going to end up having a square root in the denominator here. And so if you have something like this, let's say you have 3, let me get a thinner pen. Let's say you have 3 over the square root of x plus 7, something like this. We do not like having a square root on bottom. So we want to rationalize this. Now, when you have a binomial, what you're going to do is multiply by what we call the conjugate. And so the conjugate is basically these same two terms, but with a minus. So I'm going to take this, and I'm going to multiply the bottom by the square root of x minus 7, and the top by the square root of x minus 7. This is how I would rationalize, because rationalize means that we are trying to get rid of the square root that's on bottom. Okay, hold on, let me rewrite that. Okay, so again, the square root of x minus 7, because these are called conjugates. We know the same terms, but one has a plus and one has a minus. And I'm going to multiply this by the same thing. Okay, now this is just a sample. This is going to be something we're going to be doing in a second. I just want to remind us something from that you might have seen, should have seen, and integrated 2. So here, this is going to be 3 root x minus 21 if I distribute. And this is going to be actually a difference of 2 squares, because that's what this is when you see this. And a difference of 2 squares is basically you square this, which is x, minus, and then you square this, which is 49, and that would be your answer. Okay. So this is called rationalizing. This is rationalizing when you have a binomial. And the idea I just did when I multiplied this was if I have an a plus b times an a minus b, okay, which is what I had here, same terms, one a plus, one a minus, then that is equal to a squared minus b squared. Again, something you should have seen in integrated 1. So we're going to be using this idea to help clean up our answer. Okay, I'll show you what is probably something that a lot of us would leave us at, and then kind of how we could go from there. Okay, so let me just get rid of this. Okay, so I have space. Okay, so the very first thing I need to do is switch my x and y, and again, this really would be a y. Okay, so I am going to get x equal 3 times y plus 1 over y minus 1 squared. That's our start. Okay. Now, the next thing I'm going to do is I'm going to isolate this. So I need to divide by 3. So I'm going to do x over 3 equals y plus 1 over y minus 1 squared. Then I'm going to undo the square by square rooting. And when I square root, I get a positive and a negative. So this is going to be a plus minus square root of x over 3 equals y plus 1 over y minus 1. Now, what I'm going to do to help get these y's, which are on the same side, but they aren't combined to be like just a y, I'm going to rewrite this. When you take the square root of a fraction, you're really taking the square root of the top and the square root of the bottom. So I'm just going to move this up for a minute. So this is going to be plus or minus root x over root 3 is equal to y plus 1 over y minus 1. Now, what I'm going to do, and I'm going to come up here, I am going to cross multiply this. Okay, so here, when I multiply this, I'm going to get root 3 y plus root 3. So the root 3 multiply with my y, and the root 3 multiply with my 1. And then my root x is going to multiply with both of these, okay? And again, what's going to happen is I'm going to have a plus minus, okay? So I'm going to get a positive negative root x times y. And then this plus minus is going to multiply with this. So again, I get a positive and negative 1, okay? Now what I'm going to do is I'm going to try to get my y's on one side and everything else on the other side. So let me keep my root 3y here. And I'm going to bring this over. So that is going to be kind of like what was a plus is now a minus. So if you want to think about it like that. Okay, but again, there's still going to be a positive negative. But this is now going to be negative and this is now going to be positive. And I get root x times y equals. And over here, I am, oh, and I forgot, sorry. I forgot that I need to multiply the root x times 1, so I apologize. This is a root x. So again, this was root x times y, and then root x times 1. Okay, so I'm going to get a plus minus root x y plus, hold on, sorry, I moved that over here. I apologize. I distracted myself with my negative. Okay, so I have this. I brought this over. This is going to come to the other side. So I'm going to have a negative 3 and a plus minus root x. Okay, so now I have these y's. So this is going to be y times root 3 plus or minus root x equals oh, and this was a root 3. Did not become a negative 3. It is still a root 3. Okay, so let me say it one more time. This is staying. This I moved over here, so it switched signs. This root 3 is what I brought over here, so that should be a negative root 3 plus or minus root x, okay, because I had a plus or minus root x. And so I'm going to have a negative root 3 plus or minus root x. So now I'm going to divide by this. So I'm going to have y equal negative root 3 plus or minus root x over root 3 plus or minus root x. Okay, now that's how a lot of us can leave our answer, but I do want to show you how to clean it up by rationalizing it. Okay, so if I want to clean this up, I'm going to multiply by the reciprocal. Okay, and the reciprocal is going to be a not a reciprocal, sorry, a conjugate. So now I'm going to rationalize it. So let me just get a different color. Okay, and I'm going to scooch this over so we're just focusing. So again, this is an acceptable answer, but I want to show you if you're looking like in the math book for an answer, it would not look like this because we do not like radicals in our denominator. So what you would do is, again, you would multiply the top and the bottom by the conjugate of this. Now, this is, you have one that is a plus and you have one that's a minus. So the conjugate, again, would be opposite signs. So if this one's a plus, then the conjugate of it would be a minus. And if this one's a minus, the conjugate of this would be a plus. Root x. Hold on, let me write that better. Not very legible. Plus minus root x. And I would do the same here, root 3 plus minus root x. Sorry, and let me just kind of keep that same order just visually for us, okay? So again, if this is a plus, then this would be multiplied with the negative. If this is a negative, this would be multiplied by the plus. Okay, now when I do this, okay, and I have this root 3 minus and root 3 plus root x multiplied together, or if I have the other one, it's going to end up being the same thing. So I don't need to do it twice. What this would do is this would be a difference of two squares. I would get 3 minus x because I get a squared. A squared would be 3. And then b squared would be x. So I get 3 minus x on the bottom. Okay. Again, this one would have given me that, and this one would have given me that, because again, both of them are a squared minus b squared. Now on top, what's happening is these are not exactly the same, because this is a negative and this is a positive, okay? So when I'm doing this and I work this out, okay, I am going to get, when I do this, and I multiply this, this is going to be a root 3 times root 3, which is 3, negative root 3. If I multiply this, this is going to be a negative root 3x, and then I'm going to get another one when I multiply these. So I'm going to get a negative 2 root 3 root x. Okay, again, that's if I multiply this together. And then when I multiply this together, that's going to give me a negative x. Okay, and when I clean this up, this is going to end up giving me, again, I'm going to take the negative from here and move it up. So what does that mean? If I'm taking a negative from here and I'm moving it up, this is going to become a negative 3, and this is going to be a positive x. So I'm going to write it as x minus 3. On the top, when I bring that negative x, this is going to be a positive, a positive, a positive. So this is going to be x plus 2 root 3 root x plus 3. This is your answer in a cleaned up form. Do I expect us all to get me to this form? No. I want us all to be able to get to this black here. If you can get to here and leave it here, you're doing good. This problem is one that is a difficult problem. This one I would consider more of an integrated 3 math analysis problem than a regular integrated 3 problem. Okay? Your main focus for these is being able to switch your x and y and get your y by itself. Okay, and I think that the process of this, you should be able to get to here. Okay, get to here. This in purple here, that would be extra. Okay, hopefully you found this helpful.